In this demo, we're going to go over the basics of using for loops. The idea behind for loops is very simple. They're sort of useful in a case where you want to repeat some sort of block of code or some few lines of code over and over again. And so let me first I'll just show you briefly the syntax of what a for loop is, and then we'll go through a quick example of how to use one and sort of see where it might be useful. Okay, so first I just have a sort of empty script over here, and so let's just write a for loop. So the way for loops work is they start with this keyword for. You can see it'll turn blue in your Matlab editor. And then all for loops have to have a matching end keyword after the for loop. So these sort of always come together. Okay, and then on the same line as the for, we first have some index variable which we're going to use in our for loop. So this is a variable just like any other variable that we've talked about, but it'll so you can name it whatever you want. Then what we want is we're going to assign this variable to some sort of range of different values or numbers, right? So for starters, let's just assign it a range going from 1 to 10, right? So if I did this in this index equals 1 to 10 in my command window, you would see I would get this range of numbers as stored into my value index, right? I'm just going to clear that. Okay. The idea behind for loops is instead of assigning this 1 to 10 to index, it actually assigns them, it'll run whatever code is inside the for loop multiple times. At each time it'll assign a different value here to index. So what I'm going to do here is I'm going to say the value of index is okay. So I'm just going to print out what the value of index is, right? And so you can imagine if let's just say I did this, let's say index equal, I don't know, like 23 or something, and I ran this line of code here. I just copied and pasted it over. You can see, right, it'll just print out 23. But instead, if I run this for loop, what's going to happen is I'm going to have to save it. What happens is, what I just saved as for loop demo. What happens now is you'll see that this line of code is getting run 10 times, even though we only had the line written out once here. And so each time it's getting run, it's taking on a different index, is taking on a different value in this array 1 to 10. Okay, and so this will work with any array. So if I change this to, let's say, 5 to 15 by going by threes, right? So just to, if you remember, 5 colon 3 colon 15 takes numbers from 5 to 15, jumping by 3. If I run this line, you'll see index takes up all of those values. Okay, so that's sort of the basic idea behind for loops. You have a for line and an end line. On the for line, you have some variable. This can be named whatever you want. For example, I can just call it in IDX for index, just a shorthand. It doesn't matter what you call it. It'll still have the same behavior. And then you assign it some range of values like 1 to 10 or whatever. And then it'll run the lines of code inside the for loop multiple times where this index takes on all of those values. Okay, so to sort of see an example of where for loops can be useful, I've written this sort of little script called trig table. And so let's just go through the code here for a second just to get a sense of what it's doing. So first it clears out whatever lines are in my command window with CLC. And then I print out some header information, so this is just printing out text. I choose an angle here, so I have an angle stored in this variable called theta, which is equal to pi over 3 in this case. And then I print out this line of code, which basically prints out theta, and then sine of theta, cosine of theta, and the tangent of theta. So the sort of standard trig functions. So if I run this, you can see here I have this table where I'm printing out the angle and sine, cosine, and tangent of that angle. Okay. Okay, so that's great. But let's say, for example, I want to not only print out pi over 3, but also the value of maybe a different angle as well. So let's say I also wanted to print out the values for pi equals 4, pi over 4. So then you can imagine I can just say theta equals pi over 4, copy this line of code, and now what's going to happen when I run this is it'll give me the line printed here for pi over 3 and the line printed here for pi over 4, right? But you can imagine once you get past a couple of these angles, it becomes sort of very tedious to sort of copy and paste these lines of code over and over again. And what's worse is then let's say I want to go back and make a change. Let's say in my table I wanted to print out the angle to maybe more with more sort of significant digits. So let's say I wanted to print out this angle with 4 significant digits, right? Like that. Then I'd have to go through and make that change on every single line of code where I have that information. So that's sort of inefficient, or you can imagine quite tedious. And so one big advantage of programming languages is we can just sort of automate all of this repetitiveness with a for loop. So let's take a look how to do that. So I'm going to get rid of this second angle, and instead what I'm going to do is instead of having a single angle, I'm going to say I'm going to have this array of angles, which I'm going to say I'm going to linearly space from 0 to 2 pi, and let's say I just want to print out 10 different angles, right? And so so let's just run this line of code right here. So you can see my angles here are 10 different values from 0 to 2 pi. And so if I wanted to print out this table with 10 different values, I'd have to copy and paste this 10 times. But there's a much easier way with for loops. Excuse me. And so build a for loop to run through the angles. So what we're going to do here is we're going to say for some index equals 1 to 10, because there's 10 angles, so I'm also going to run my index from 1 to 10. Now, current angle. Now what I'm going to do is I'm going to say, instead of theta being equal to pi over 3, what I'm going to say is I'm going to let theta be angles of index, right? So index is going to go from 1 to 10. So let's say we're in the first iteration of the for loop, and index is equal to 1, right? Then angles of index will be equal to 0, right? Let's say we're on the next iteration of the index equals 2, then angles of index is going to be 0.6983. So you can see this variable theta is going to change on every iteration of this for loop depending on what the sort of current value of angles of index is. And so we're just going to sort of step through every value in this array, right? And so what we're going to do then is just print out the line of code that we used to print out the table is going to be the exact same, right? It just depends on what theta is. And then we just have n to close the for loop. And so another thing, it's sort of considered good coding practice to indent any lines of code within the for loop. So the idea there is it just sort of makes it easier to see what code is part of the for loop, and sort of it separates it from the rest of the script. So it's sort of good practice to indent things inside of for loop. Okay, so let's just run this script, and you can see here I have very nicely laid out 10 angles and the sine, cosine, and tangent of all 10 of those angles. A couple of points. So one thing is it's another sort of good programming practice tip is it's very useful to, instead of having a 10 here and a 10 here, let's say for example I wanted to switch this and print out maybe 20 lines in my table, right? But then I'd have to also remember to go through here and change this to 20 as well. I have to sort of change two things in two places. So what's considered better practice is to sort of instead of using 20, you can sort of hard coding that number in. We can just get at that same value by just taking the length of angles, right? So this is going to sort of go from 1 to however long angles is, because the length of angles is just the length of that array. So that way now we can change this to 50 or 15 or whatever we want, and this will automatically sort of update to the right value. So we only have to change things in one place. Okay, so yeah, so I run that, and it's this for loop runs the same way. Some of you may have noticed that we actually don't even need the index. So this script runs fine, it runs great. If you want to even sort of simplify things further, what we're doing is we're running the index here from 1 to however long this is, and then indexing into the angles array. But like I said, the for loop will run over whatever values are in the right side of this statement here. And so it doesn't actually matter if we index from 1 to the length of angles. Instead, we can just say for theta equals angles. And what that will do is it'll actually let theta run over all of the values in angles. And so that will actually have the exact same result, and sort of a simpler simpler way to do it. But both ways work, and both are fine. Okay, so hopefully that sort of gives you some sort of clue into how for loops work. And so the real beauty of this is now to the computer, it doesn't matter if I want to, even if I want to print out 1,000 lines, it can do that almost instantaneously. And you can see here it's printing out 1,000 lines here in this table. And so it's sort of a really great way to sort of automatically run sort of lines of code over and over again.